Hi guys. So today we're going to learn how to use something called algebra tiles. Some of you may have used them in the past, some of you may not, but either way, this is actually one of my favorite manipulatives because personally I'm a very visual learner, and I know sometimes like the Cuisenaire rods just seem frustrating or confusing, but personally this is my favorite of all the manipulatives we use in grade 8 because I feel like they just make sense. So we're going to go through 12 questions together, and I'm going to be doing a little bit of something new. I'm going to be bouncing back from this screen to another screen, and we'll see how it works, so bear with me here. But we're going to go through them symbolically as well as physically using algebra tiles. Obviously, we would normally have physical tiles, but in this case, you're just going to get to watch along with me, okay? So our first question is x plus 1 equals 4. And most of you hopefully would find this very easy to solve for. Oh my goodness, come on. X plus 1 minus 1 equals 4 minus 1, right? So we're getting rid of this 1 on the left side so that we can get x alone. And what we do on one side, we do on the other. So that leaves us with x equals 3. So now I'm going to show you how to do it with algebra tiles. So this is a cool little thing I found. I would highly recommend that you pull it up right now on your own computer as you're watching this video so you can do it along with me, okay? Just to go back to our other screen. When we're talking about algebra, we think of the equal sign as basically as the center of a scale that we don't want it to tip back and forth. We want it to stay even. So if we were going to write this equation on our scale, right, it would be x plus 1 on this side and 4 on this side, which really clearly shows the idea of, what you do on one side, you have to do on the other. Because if we, for example, if we added minus 1 on this side, well, that would change the weight, so we would need to add it on this side as well. So to represent that over here, I'm going to hit my horizontal and vertical, and this represents this scale, with the center line being the equal sign. Now, let's quickly go through kind of what these mean here. These are our variables, okay? So variable just means whatever number we don't know. So in this particular case, x is the variable. We don't know what x is, we want to find it out. And in our case, this x is positive. So we would represent x with one of these green ones. If it was a negative x, we would represent it with one of these red ones. If it was 2x, we would have 2 of these. If it was 3x, we would have 3 of these. But it's 1x. And these little guys, these represent just regular numbers. So this yellow one is a positive and this red one is a negative. So in our question, we have plus 1. So here's our plus 1, but if it was plus 2, we would have 2 of these. If it was plus 3, we would have 3, right? We only have plus 1 at the moment. If it was negative 1, we would use this. If it was negative 2, we would use this. If it was negative 3, we would do 3. Okay. So let's see. Let's just jump right in. So we have x plus 1 equals 1, 2, 3, 4. Awesome. Okay. So right now this is balanced, but we want to figure out what x is by itself. So we got to get rid of this guy. And to do that, we're going to use something called zero pairs. So we all know that, I'm just going to go back to my other screen for a sec. We all know that 1 minus 1, so basically plus 1 minus 1 equals 0, right? And that's the idea of a zero pair. So if I have a plus 1 and a minus 1 on the same side, they zero each other out, and they basically cease to exist. So to get rid of this, I'm going to use a zero pair. And you have to remember, though, what I do on one side, I have to do on the other. So now I can get rid of this because it created a zero pair, and this one created a zero pair as well. So these no longer exist. They're gone. We're not even looking at them. They don't exist anymore. We're only looking at this, 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 and this. So we've basically got our answer here. X equals 3. Awesome. Okay, let's go to another question. Question number 2. X minus 1 equals 5. Okay. Let's go to our pairs. Tidy it up. X minus 1 equals 5. So I have a positive x. There's my positive x. This time we have a negative 1. And on the other side, it says it equals 5. 1, 2, 3, 4, 5. Okay. I still want to get that x alone. So I'm going to create a zero pair to get it out of there. And what I do on one side, I have to do on the other. So this is gone now. But this guy still stays here. So x equals 1, 2, 3, 4, 5, 6. And let's check symbolically to make sure that we're right. X minus 1 plus 1 equals 5 plus 1. So x equals 6. We were right. Okay, let's do question number 3. 2 minus y equals 4. Now don't forget, when we're talking about a variable could be represented by any letter. It doesn't have to be x. It could be p or q or k or whatever you want. Usually we use x and y, but sometimes there's going to be more than one variable in an algebraic expression. For now, we're just sticking with one, but sometimes you need more than one letter. So let's jump over to here. Oop. Wow, why did I get suddenly very close? There we go. Put my, and now I'm suddenly very far, whatever. Okay, let's see. 2 negative y equals 4. Okay, haha. So our 2 is actually still positive. 2 is positive, okay? It's the y that's negative. So instead of representing it with one of these green ones, we have a negative y this time. And it equals 1, 2, 3, 4. Okay, so we're just going to follow the same thing we've been doing, which is getting that y by itself, that variable by itself. So I'm going to put these here. What I do on one side, I have to do the other. So I have a couple zero pairs, so I can get rid of those. And here I essentially have my answer. I'm totally okay with you guys leaving the variable negative. Negative y equals 2 is a perfectly acceptable answer. Now, you could switch it so that the variable is positive, but you don't have to do that. To switch it so it's positive, you'd go like this. These become a negative pair, just like on the other side. And then I would move these over to here, where they would become negative. And there we have it. We've switched our variable so it's positive. y equals -2. But like I said, I'm totally okay with you expressing this with your variable being negative. So let's do it symbolically. Let's see, 2 minus 2 minus y, or negative y, equals 4 minus 2. So these cross each other out. Negative y equals 2. Again, this negative, this is totally fine with me. Okay, question number 4. We're getting into multiplication. 2x equals 4. So just like when we were talking about multiplication, okay, there we go, that's better. Just like when we were talking about, sorry, not multiplication, subtraction and addition, where subtraction is the opposite of addition and addition is the opposite of subtraction. Multiplication and division are opposites of each other, the same way. So our question is 2x equals 4. So it's not 2 plus x here, it's 2x, which really means 2 times x, okay? So we're going to have 2 x's here, and it says it equals 4. So we'll have positive 4 over here. Now, some of you are sitting here looking at this like, what the heck? What am I supposed to do? You don't have to move anything because the x's are already on their own side alone. And here is where we get to do something kind of fun. Normally I find this very satisfying to do with actual tiles, so it's going to be slightly less satisfying here. But I'm just going to flip my variables so that, like my tiles, not my variables, flip my tiles so that they're sideways because I find this really easy to see. But we're basically just dividing this into 2 because division is just groups of something, right? So I have 2 variables and I want to divide it into 2, so I'm just going to split these into 2 even groups. So now I have 1x equals 2. So each x is equal to 2. Awesome. Hopefully that made sense. We'll do a few more as examples. Let's make sure we know how to do it symbolically as well. So 2x equals 4. And this is where we would be flipping our tiles around. So x equals 2. We were right. Okay, question number 5. 2x plus 1 equals 7. 2x plus 1 equals 7. Okay. So let's see, I have 2 x's. 1, 2. Actually, I can see already I'm going to have to split these, so I'm going to do them like this. 2 x's plus 1 equals 7. 1, 2, 3, 4, 5, 6, 7. Okay. So I want to get my x's alone. So I use my 0 pairs. Get out of here. So again, actually, I kind of already set this up, but we can see we're going to have to divide here. And I've kind of already put it into visually 2 groups. So 1x is equal to 3 tiles. Easy peasy. 2x would be equal to 6. But we only want 1x. We want to just know what x is. So x is equal to 3. Let's double check here. So 2x plus 1 minus 1 equals 7 minus 1. 2x equals 6. We divide. X equals 3. We were right. Okay, question number 6. 5 equals 1 minus x. Okay, 5 equals 1 minus x. Let's go over to here. Okay, so let's see. We have 5, 1, 2, 3, 4, 5 is equal to 1, because the 1 is positive, and then negative x. So we're using a negative variable, negative x. Let's see, I still want my x to be on its own, so I'll use my 0 pairs here, and I can get rid of them. And here's my answer. Negative x is equal to 4. Now again, I could change this into a positive by doing this. 1, 3, 4, 1, 2. Oh gosh, I ran out of them. 3, 4. But that is completely unnecessary. I don't need you guys to do that. I don't mind you expressing a negative variable. So let's see, let's check our work here. Personally, I find it easier to flip equations like this around because I just find it easier to have the x on the left. That's just the way my brain works. So if you're the same way and you want to flip it so that it's like this, you can. Remember, it doesn't matter which side of the equal sign it's on. It's still equal, right? But it really doesn't matter. So positive 1 minus 1, negative x equals 5 minus 1, negative x equals 4. Awesome. Okay, so the next 1, 2, 3, 4, 5, 6, the next 6 questions are going to start getting a little bit